Okay, question number 144. We have a 5 Newton here. So this is acting in the z direction but negative. So we will put minus 5k for the force, negative 5. Why? This is the line of actions. Actually, it should be dashed line. And as you see, this is parallel to the z. So the unit vector of the z is k, but here it is pointing in this direction, which is negative. So we will put minus 5k. Now we need to find the coordinates of the point O, because we need to find the position vector of this force. So how can you find this? There are one way. So this vector is a sum of AB plus BC plus CD. Okay, so we need to find first AB. AB is, length of AB is 50 millimeter. So we will put all of the dimensions here in millimeter, because we don't have any meter, and then we will change it to meter later if you want. So this will be 50 cos 30. It will be this length. So 50 cos 30 will be this length. And what about this length, vertical part? This vertical part, so this angle is 30. So it will be 50 sine 30. 50 sine 30. So first we need to find AB. And in the question it is said that the crank BC is horizontal. So it means that this BC is parallel to the y-axis, positive. So now I need to vector of BC, this one's. So this is in the y-axis. How much is this length? 75 millimeter. What is the unit vector of the positive y? It is j. So I will put 75 j. Okay, what about this ones? This is parallel to AB. So if this is 30, this will be also 30. So there are two options here. So let us go for the first options. So you can find this vector here, CD. So how much is this? So it is exactly 30 degree. So it has two components. One of them is exactly parallel to the x, and it will be 25 cosine 30 degree. And the other one will be 25 sine 30. Okay, sorry for moving this. And yeah, we can easily find the point D. Here I show you the point B, C. You can just check your answer. After that, we know AD, because the dimension of this point minus 0, 0, 0 will be this. And this is the position vector. We have already expressed the F as a vector here. R cross F, the product of the position vector times the force vector. Use the determinant, and we obtain the determinant. And now the question asks about the determine the moment of the force about point A. We have already obtained this one, and about line AB. So you need to find the unit vector of AB. But let us first obtain AB. So for AB, as I said, this is 50 cos 30, and 50 sine 30 is the vertical components. What is the vertical components? Okay, let us show you. So 50 cos 30 and 50 sine 30. Remember, this is not J, this is parallel to the Z directions, and the unit vector of this one is K. So the AB will be this. How can we obtain the unit vector? We will just divide the AB to the magnitude of the AB. How much is the magnitude of AB? You can easily say that it is 50, but if you don't know, you can just use square this one and square this one. You will just add them up, the square root of this, which is this. This will be 50. And finally, the answer will be this. But remember, when you have a magnitude like this and cosine 30 and again magnitude times sine 30, always you can get rid of 50 and the unit vector will be cos 30 sine 30. Sine 30 is 1 over 2 and cos 30 is, cosine 30 is a square root of 3 divided by 2. So this is the formula that we need to memorize. R cross F dot the unit vector, the dot product of the moment and the unit vector times the unit vector. So first we need to obtain this. So we have already obtained the R cross F, which is this. And also we need to do the dot product of the MA times this, which will be, okay, let us obtain this part first. So R cross F is how much? R cross F is this one. This one, we don't care about the, Newton millimeter. So dot product means that you need to find the corresponding components. For example, here we have negative 375. This is the I component, okay? I will highlight this. And what about here? So we have the corresponding components here. So this will be multiplied by negative 375. This is the first one. J component of this one is 324.76 times 0. So it will be 0. And again, I will write it here. And what about the other one? 324.76 times 0. J component will be multiplied. And here the K component is 0 times 1 over 2. So this will be the answer. We need to find this. How much is this? Let us use the calculator. So 3 squared divided by 2 times 375. It will be 325, but it has a negative minus. Okay, so this is negative sign is very small. Yeah, I will just copy instead of this part 300 sorry, negative 325. Remember, this is equal to this, and then you will multiply 325 by root square. Let us do this one too. 3 root square, 3 square root 3 will be this, and divided by 2 times 325. Don't worry about it, will be 281, and also you can obtain the last one, 325 divided by 2, 162.5. Make sure that it will be the negative part, please.